Imagine time as a river seen from a mountaintop. At first it moves gently, seconds rippling into minutes. Then the valley opens, the water widens, and the current begins to roar. Our mission is to step into that flow and ride it calmly all the way to the farthest shore, the end of time. We want to feel the sweep of ages with plain words. Right now, your body keeps its own clocks. A heart taps once each second. A breath sets a slower beat. The moon circles us in a month. Earth loops the sun in a year. The universe keeps larger rhythms, pulses that last millions or trillions of years. To hear them, we loosen our everyday sense of time and let our minds stretch. Here is our map. We begin with the familiar world, then travel beyond the span of civilizations, beyond the lifetime of the sun, beyond the last spark of starlight. We will pass eras with names that sound like poetry, degenerate, black hole, and dark, until even names grow thin. When numbers grow huge, we will use simple comparisons. First, anchor in the present. Night sweeps across Earth. Green auroras ripple at the poles. The air thins into the quiet of orbit. Satellites slip by like patient fireflies. The sun hums a steady chord powered by the joining of atoms. Tiny hydrogen becomes helium, and the difference shines as light. NASA tells us our star has fuel for billions of years ahead. Tomorrow's daylight is secured. Promise is not immortality. The fuel will change, and the music will shift. In the far future, the sun will swell and redden. Mercury and Venus will be swallowed. Earth will be scorched or nudged outward. But that is later. For the first stretches ahead, no catastrophe breaks the sky. Continents drift. Ice ages come and go like slow breaths. Species appear, flourish, and fade. Human monuments soften back into hills. Time is patient, and patience is powerful. To feel the scale, picture a city-sized calendar. A single block is 1,000,000 years. A neighborhood is 10 million. A loop around the Beltway is 100 million. On that map, the sun spans districts. Human history is a short alley. Past a few million years, the stars themselves drift. Constellations melt and reform like fireworks rewinding in slow motion. The North Star retires. A new guide takes its place. Deep in the Milky Way, our spiral home of hundreds of billions of suns, a shadowed giant sits at the center. A black hole, quiet and heavy, shaping the inner dance. Gravity is simply how mass curves space, and curved space guides everything that moves. Farther ahead, neighboring galaxies slide like islands on a dark sea. Our nearest large neighbor, Andromeda, is on a slow approach. Not a crash of billiard balls, but a weaving of two star swarms. The most likely future is a graceful merger where stars mostly miss one another, and the two islands blend into a new, larger country of light. If you could time-lapse the sky over billions of years, you would watch new rivers of stars arc across the darkness. As we proceed, another clock begins to matter, the half-life of memory. Languages split and braid, books decay, cities sink under dust. Even the atoms in our bodies, which feel so permanent, are travelers. Iron forged in ancient stars circulates in your blood. Calcium from long-gone seas rings your bones. On human timescales, we inherit the world. On cosmic timescales, we borrow it. There is quiet comfort in that. We are not outside the timeline we are about to explore. We are its newest chapter. The atoms that will someday drift in the dark existed in other forms before us, and will exist in other forms after. This is not a loss, it is a larger belonging. Think of the universe as a symphony with movements. The opening was bright and hot. Later movements grew cool and spacious. We are listening somewhere in the middle, during the great era of stars, when galaxies glow, planets weather, and chemistry tries ideas like life. What happens when the symphony slows? Stars fade. New stars grow rare. The stage lights dim, and the music drops to notes so deep we can barely hear them today. Before the dimming, there is an age of making. Even now, clouds of gas fall together under their own weight. setting off stellar dawns. Around many newborn suns, dust gathers into planets. Some worlds are scorched, some frozen. A few balance in the gentle zone where liquid water can linger. If life is as curious elsewhere as it is here, it will look up and ask the same questions we ask. Where did everything come from? How long does it last? What happens after the last page? How can we guess at answers? We know the broad strokes. Physics gives the rules. Observatories on the ground show us stars at every stage of life. By lining up these snapshots, we build a film and read the pattern. From that pattern, we extrapolate. We expect surprises. Nature enjoys them, but the outline is sturdy enough to guide a journey. So take one more look at the present. A blue world lit by one steady star. Oceans breathing tides under a patient moon. Cities sparkling like constellations on the night side. Fix that picture in your mind. In a moment we will widen the lens and let years blur into centuries and centuries into eons. The river is quickening. The horizon is opening. The timeline ahead is not a cliff, it is a coastline. We will trace it, step by step, era by era, to the end. When you are ready, breathe in and hold it for a heartbeat. That is the length of our launch pad. Exhale, and we begin. We begin our time-lapse gently, with scales your mind can hold. Picture a timeline like a beach at dusk. Closest to your feet are the next decade's warm sand, familiar footprints. Farther down, the shore turns blue, and the lights of the present fall behind us. Keep walking. We will stay calm and curious as the years open. In the next centuries, Earth keeps breathing. Winters and summers still trade places. Storms still spin and fade. Cities rise, age, and crumble into quiet mounds that grass and trees reclaim. Languages braid into new music. The constellations you know loosen a little. The Big Dipper tips and stretches, and Polaris, our North Star, slowly retires as a new guide star drifts into place. Nothing breaks. The clock is steady. A few thousand years on, coastlines redraw their edges. Rivers, patient as monks, move mountains grain by grain. The Sahara breathes in and out on slow cycles, greener in one era, drier in the next. Ice leans south, then draws back north. On this scale, humanity's stories are sparks in tall grass, bright, brief, and many. Some sparks catch, and the memory they leave changes what comes after. We may not know the names, but the pattern continues. Living things adapt. Glide forward to tens of thousands of years. The sky above no longer matches the star charts of today. The patterns are different, but the feeling is the same. A river of light overhead, Milky Way dust like fine chalk across slate. Out in space, our steady sun hums on. Inside its core, hydrogen nuclei still press together, and the difference between before and after shines as light and warmth. This is the long summer of our star. It has lasted for billions of years, and still has billions to go. 100,000 years from now, glaciers may again brush the continents in a slow parade. Or perhaps they pause. Climate is a dance of many partners, and the tune shifts over long spans. Deep underground, continents slide on molten currents. Mountains rise where plates meet. Old seas close, new seas open. The map you learned in school becomes a memory of a moment. 1,000,000 years from now, everything familiar is still here in spirit, but the details have drifted. The night sky is a new tapestry. The constellations your descendants trace will rhyme with ours but not repeat them. Somewhere far past the planets, a passing star may stir the sleeping comets at the edge of our system. Some ice-dark travelers fall inward, sketching long tails in the inner light before they fade back to cold. 10 million years. The Grand Canyon is deeper, the Andes higher, the African rift wider. Life continues its tireless experiment. Stripes, shells, feathers, fins, the toolkit of nature, reshuffles. Most species born today will be gone by then, and others, entirely new, will take their places. Extinction sounds harsh, but on these scales it is a turn of the page. The story keeps going. 100 million years. Imagine rolling Earth like a marble beneath your thumb. The continents have wandered far. Perhaps a new supercontinent is gathering, or perhaps the land is scattered in island chains. Tropical forests grow where tundra once stretched. Deserts bloom where oceans once rested. The moon has inched away. Days are a little longer, tides a little gentler. Above, the Milky Way's spiral arms drift like slow clouds. To our eyes, the galaxy still looks serene. Now we reach the first great bend in our river, the far future of Earth's climate under a brightening Sunday. Stars like ours do not burn fuel at a constant rate, they age and heat up. Over hundreds of millions of years, the sun's gentle increase adds energy to Earth's skin. At first it is subtle, a degree here, a shift in the seasons there. But by around 1 billion years hence, that small change has big consequences. Oceans evaporate more quickly than rain can return them. The air grows thicker with water vapor, and heat lingers. Blue fades toward tan. The planet that once sang with rain and rivers grows quiet. This is not a sudden catastrophe, but a slow change, a twilight long enough for many chapters. If any descendants of life remain, they adapt in ways we can barely imagine, or they look outward to shaded worlds, to artificial shelters, to other suns. The idea of home stretches. Fast forward to 2, 3, 4 billion years. The Milky Way and Andromeda draw close enough for their stars to trace long, graceful bridges of light between them. From some places, the night sky would bloom with arcs and plumes, like petals poured out across darkness. Despite the scale, collisions between individual stars are rare. Space is mostly space. Gravity's art here is weaving, not smashing. After the dance, a new, larger galaxy settles down. A mellow glow of ancient suns and long orbits. At roughly 5 billion years from now, our sun leaves its comfy middle age. The core, robbed of its easy fuel, tightens and heats. The outer layers expand and redden. We call this a red giant, but the words red and giant understate it. The sun swells until it fills much of the inner system with a warm copper fog. What happens to Earth is uncertain. Some models suggest the swollen star will engulf our orbit. Others suggest drag will pull Earth inward to a fiery end. Still others leave a narrow door open where a charred, airless Earth survives just beyond the sun's reach. All versions agree on this. Seas, air, forests, cities, long gone by then. Near the end of the red giant chapter, the sun sheds its outer layers into space, a delicate nebula shaped by the last sighs of stellar wind. From a distance, it would look like a breathing blossom shells of gas expanding, glowing softly, then fading. What remains at the center is the sun's small, hot heart, a white dwarf, Earth-sized and ember-bright. No more fusion, just the long, slow cooling of a stellar remnant that will take trillions of years to fade. Pause here. We have crossed from the age of comfort into the age of memory. The sun's wide evening is over. The porch light has become a coal, but the universe beyond is still full of stars. New ones still form in dusty nurseries. Old ones bow out. Planets in other systems trade seasons and surprises. Our local story is changing, but the galactic canvas remains alive for now. Why walk this road? Because the future is not only a list of endings, it is a scale that gives meaning to the present. Knowing that summer fades makes summer sweeter. Knowing the sun will someday dim makes today's sunlight a gift. We stand at a balcony in the middle of the symphony, listening to a movement that will not last forever, and that makes the music richer. From here, our path will leave the warmth of starlight and enter colder halls where red dwarfs burn on like coals in a winter stove, where the last new stars flicker into being, and where gravity, patient as always, writes its slow script. When you are ready, step with me into the long twilight of the cosmos, the era after the Sunday. Step forward with me into the long twilight of the cosmos, the era after the Sunday. Our home star has cooled to a white dwarf, a hot ember the size of Earth, glowing without a flame. Around it, the inner system drifts like ash. But look beyond our porch light. Across the galaxy, the night is still alive. The brightest actors now are the faintest ones. Red dwarfs, small stars that sip, not gulp, their fuel. Red dwarfs burn like pocket stoves. They are dim and cool by stellar standards, yet they make up most stars. Their secret is patience. Where the sun lasts about 10 billion years, some red dwarfs can shine for trillions. A trillion is 1,000 billion, a span so wide that human history is a blink inside a blink. In this era, most of the light in the universe is soft red, thrown by tiny suns that never hurry. Planets that circle red dwarfs live close in, because warmth fades quickly with distance. Many are tidally locked, showing one face to their star forever, as our moon does to Earth. That means a day side baked in constant light, a night side deep frozen, and a thin twilight ring between them where temperatures may rest in the middle. If life finds a way here, it might gather along that band a permanent evening, with long winds streaming from day to night. When red dwarfs are young, they often flare, tossing out bursts of energy. With age, their temper settles, and many become steady hearths. On their quiet worlds, a year could last a few days, a sunrise could take weeks, and civilizations, if they arise, would grow under a ruby sky. While the little stars endure, the galaxy's nurseries slow down. The Milky Way, now merged with Andromeda into a swollen system, has used much of its cool gas. New clouds are harder to light. Supernovas have blown many regions thin. Black holes have heated others. Starbirth becomes rare, like a once-a-year fireworks show. The sky itself changes character. Today, we know a river of light called the Milky Way, a bright smear made of countless distant suns. In the later eons, that river fades. The blue-white beacons, the hot, short-lived stars, have burned out. What remains is a peppering of red and orange points, and the slow glow of ancient clusters. Gravity continues its quiet work. Star clusters evaporate as members drift away. Planetary systems are nudged by close passes. Many planets are kicked free entirely. They become rogues, wandering the dark between stars with only the heat of their own cores for company. The cast of stellar remnants grows, white dwarfs cool and yellow. Some live in pairs, and after long spirals inward, two can merge. If their combined mass passes a threshold, the result is a thermonuclear flash, a Type Ia supernova brief noon in a patch of night. Far across the galaxy, anyone looking up would see a new star bloom, linger, and fade over months. These events grow rarer as time stretches, but they do not vanish, and each one seeds space with heavy elements, the raw parts for rocky worlds, oceans, and life-friendly chemistry. Neutron stars remain two city-sized spheres of crushed matter. Once in a great while, two collide and ring the universe with ripples in space-time. In the depths, supermassive black holes at galactic centers continue to feed when a star strays too close. A tidal disruption event, such an apt name, shreds the star into a bright spiral of gas that flares, then sinks. Brown dwarfs' failed stars also haunt this era. Too small to sustain a steady burn, they glow from leftover warmth. A traveler could live a long life and never see a sunrise, yet still stand on a world warmed from within, under a sky full of faint neighbors. Lift now from billions of years to trillions. If a billion years is one long breath for a star like the sun, a trillion years is a deep winter's sleep for a red dwarf. One by one, even the thrifty stars run low on fuel. They dim, redden further, and finally settle as white dwarfs. The galaxy ages into an archive. White dwarfs like file boxes, neutron stars like iron stamps, black holes like locked vaults. The aisles grow quiet. Dust still drifts. Odd sparks still happen. But the steady chorus of new stars has faded. Galaxies themselves change under this slow pressure. Gravitational nudges fling many stars to the edges and beyond. Bit by bit, the great island loses members to intergalactic night. The ones that remain sink deeper into the shared gravity well, circling the central black hole like patient moths around a lamp that gives no light. Now and then, Long after the last ordinary star is born, a new kind of star briefly appears. A white dwarf can pull gas from a companion and ignite a surface blaze called a nova, a skin-deep star, bright and temporary. It is a reminder that even in the far future, fire can still find a wick. Pause and listen. The universe has not ended. It has changed tempo from a bright, busy youth to a seasoned middle age, and now to a reflective late chapter. What it loses in sparkle, it gains in endurance. The lights that remain are steady and old. The spaces between them are wide and calm. This is the threshold of the degenerate era, the age ruled by remnants. Ahead lie black dwarfs that have cooled for unimaginable spans, black holes that shape the fate of everything nearby, and a question at the bottom of physics: do the smallest pieces of matter last forever? To find out, we step across the threshold and keep going. Step over the threshold, the bright age of starlight is fading behind us, and the degenerate era begins. This is an age of leftovers, quiet, sturdy, long-lived. White dwarfs, neutron stars, brown dwarfs, and planets drift on wide, slow orbits. The universe has not gone silent, but the notes are low and sparse. White dwarfs are the most common actors now. Each one is a sun's bare core, small, dense, and hot, left after the outer layers floated away. With no new fuel to burn, a white dwarf simply cools. It radiates its stored heat for a very long time, dimming from white to blue to yellow to red, and finally to a glow so faint it is more idea than light. Given enough time, it will cool into a black dwarf. The same object, only cold and dark, a cinder the size of Earth. No one will ever see a true black dwarf today. The universe is not old enough yet. But in the far future, whole constellations will be made of these invisible points. Neutron stars persist, too, city-sized spheres of matter packed tighter than an atomic nucleus. Some keep spinning for ages, sweeping space with lighthouse beams of radio waves. Most slow down and fade, becoming quiet lumps that still weigh more than a Sunday nearby. Brown dwarfs, objects too small to ignite, as stars glow gently from leftover warmth. They are the dim embers between stars. Planets survive in large numbers, but their loyalties shift. With every close pass, gravity nudges orbits. A brush here, a tug there, and over eons many worlds are thrown free. They become rogues, planets without suns, wandering the dark. Some still hold heat inside from their birth. Thick blankets of rock and ice trap that warmth. Under miles of frozen shell, seas can remain liquid. If life ever learned to live by inner heat rather than starlight, this is where it might last the longest. In buried oceans lit by faint chemistry and slow currents, under skies that never see dawn. The galaxy's personality changes. It used to be a place of bright nurseries, superbubbles blown by supernovas, and blue giants that lived fast and died loud. Now the nurseries have thinned. Gas that once made stars is locked up in remnants or heated too much to settle. New star formation is rare. The Milky Way, long merged with Andromeda into a single swollen city of stars, turns into an archive. Shelves upon shelves of stellar fossils orbit the center. The shelves do not stay put. Over long spans, gentle pushes called gravitational relaxation shuffle the residents. Some are sent outward to the dim suburbs and beyond, slipping into intergalactic night. Others fall inward toward the central black hole. Even in a quiet era, fireworks sometimes happen. Two white dwarfs in a tight dance can lose energy to faint ripples in space-time and drift together until they touch. If their combined mass crosses a threshold, a sudden thermonuclear blaze tears through the pair, a type Ia supernova. For months, a patch of darkness blooms into a new star bright enough to rival an entire galaxy in that small region. These events become fewer as time stretches, but they do not completely vanish. Each one flings heavy elements back into space, adding to the stock that once made worlds like ours. Across the universe, the background light itself is changing. The afterglow of the Big Bang, the cosmic microwave background, was once a warm fog, then a radio whisper. As space keeps expanding, that whisper is stretched thinner still to wavelengths too long for almost any detector. The universe cools toward absolute zero, never quite reaching it, always approaching. Darkness here is not empty. It is simply too stretched and cold for ordinary eyes. On timescales so large they mock our words, white dwarfs become black dwarfs. The matter inside them sits in a strange, compressed state, stable only because quantum rules say the particles cannot all occupy the same place. Do those particles last forever? We do not know. If the proton, the basic brick of atoms, eventually decays, then matter slowly leaks away over fantastically long spans. If protons are truly stable, the black dwarfs endure. In both cases, the pace is glacial beyond imagining. There is a curious possibility at the edge of theory. Even without fuel, a black dwarf's atoms still obey quantum chance. Over times with more zeros than we can write, those chances may allow new reactions to creep forward inside the core, step by tiny step. In some models, this ends in a quiet but real supernova, a last flash from a star that has been dark for ages. Whether nature permits, this is an open question. If it does, those rare flares would be the universe's very late punctuation marks. Meanwhile, gravity continues its slow script. Binary remnants merge. Star clusters dissolve. The great galactic halo thins as members are lost to the void. In the crowded center, the supermassive black hole grows in small bites, swallowing the occasional star, dwarf, or unlucky passerby. Each meal lights a brief beacon gas, stretching into a bright, hot spiral before crossing the point of no return. These flickers become the main sources of light in very old galaxies. Life, if anything remains, hugs special niches. Under ice, near geothermal cracks. Inside, thick atmospheres around warm cores. Perhaps aboard engineered habitats that sip energy from radioisotopes or harvest the rare light of a passing flare. The rhythms are different. Years without change. Then a single event that matters. Patience is not just a virtue here, it is a survival strategy. What does time feel like in such an era? Imagine standing on a dark plain with mountains far apart. Nothing moves quickly. The sky is a sparse field of red and infrared points. A glow rises once in a lifetime when a distant remnant ignites or falls. Then darkness returns, deep and kind. If awareness looks out from such a place, it would measure life not in days, but in epochs between rare lights. We have walked far from the warm middle of the cosmic symphony. The music now is minimal, long notes, long rests, and an occasional drumbeat from a merging pair. Ahead is a different movement still, the black hole era, when almost everything that remains either orbits a black hole or is one. Black holes are not evil or magic. They are simply regions where gravity has won completely. They can curve space, trap light, and slowly lose mass by a faint glow called Hawking radiation. In that era, even the darkest objects begin to fade. We will enter that chapter next. The stage will grow quieter, but not empty. The universe still has one last act to play, and it belongs to gravity itself. Step quietly into the black hole era. The bright age of stars has long passed. What remains are islands of matter circling wells so deep that even light cannot climb out. This is gravity's endgame, calm, patient, absolute. A black hole begins when enough mass is squeezed into a small region. Space curves so sharply that all roads fall inward. The edge of no return is the event horizon. Cross it, and every path forward leads deeper in. Stay outside it, and you can safely orbit and even skim the rim. In the far future, many survivors, white dwarfs, neutron stars, lonely planets spend their last long orbits around black holes. Near a horizon, infalling gas forms a hot whirlpool called an accretion disk. As it spirals down, it heats and shines. Sometimes magnetic fields launch thin jets that pierce the dark like needles of lightning. In the young universe, such feasts powered quasars, the brightest beacons in the sky. In this late era, big meals are rare, but not gone. A stray star wanders too close, is tidally shredded into a ribbon, and a brief flare marks the loss. Black holes come in sizes. Some weigh a few suns. Others at galactic centers hold millions or billions. These giants grew by eating gas, stars, and each other. When galaxies merged, their central black holes danced for eons and finally coalesced. The last steps of that dance shook the fabric of space, sending gravitational waves outward, ripples no eye can see, but the universe can feel. Meanwhile, cosmic expansion keeps stretching the map. Dark energy, the name we give the push that speeds this expansion, carries distant galaxies beyond any chance of contact. In time, only the local family remains bound. Our merged milk dromedar, a few dwarfs, and their central black hole. The sky grows simpler. The lights left are near, old, and red. Around the giant at the center, orbits decay very slowly. Stars and remnants exchange tiny nudges that trade energy. Some are kicked to escape forever, others are coaxed inward until tides tear them apart. Each feeding lights a brief ember in the dark, the last fireworks of a quiet city. What lies inside a black hole is hidden by definition. Our best math points to a place where densities climb without limit, a sign the math is incomplete. Somewhere beyond the horizon, gravity and quantum rules must meet on equal terms. We do not yet know the final law they write together. The mystery is part of the beauty. From the outside, though, black holes are simple. Mass, spin, and electric charge fully describe them. Over time, charge drains away, and spin can slow. Mass dominates. And mass does something unexpected. It glows, not bright or fast, but steadily. A black hole is not perfectly black. Here is the idea in plain words. Even empty space flickers with brief pairs of particles that appear and vanish. Near a horizon, one can fall in while the other escapes. To a distant observer, the whole has given off a particle. This slow leak is Hawking radiation. The bigger the black hole, the colder and slower the leak. Small holes evaporate faster. Supermassive ones take a staggering length of time. Imagine a lone asteroid-mass black hole. It would vanish relatively quickly on cosmic terms, ending in a sharp, hot flash. A stellar-mass black hole lingers far longer. One with the sun's mass would take a number written with 60+ zeros in years. The giants at galactic centers would outlast almost everything else by numbers so large they are better felt than said. The point is simple. Given enough time, even the darkest objects fade. As black holes evaporate, they return their energy to the universe as a thin drizzle of particles and light. The last moments are the brightest, as the shrinking horizon produces higher energy radiation. Think of embers that glow faintly for a night and then end with a final spark. In this far era, those sparks are among the last true flashes of light. Between these rare endings, the cosmos is quiet. The afterglow of the Big Bang has been stretched to wavelengths larger than galaxies. Neutrinos, ghostly particles that slip through almost everything, outnumber all atoms and carry on through the dark. The universe is not empty, but it is thin, cold, and slow. If protons eventually decay, matter itself will slowly dissolve into lighter particles and radiation, turning stars' ashes into mist. If protons are stable, black dwarfs and neutron stars hold on far longer, but gravity will still steer most of them either into escape or into black holes that, in the end, evaporate away. Either way, the inventory of heavy, complex, well-lit structures shrinks toward zero. What does time feel like when events grow this rare? A calendar would show vast blank pages punctuated by a single dot, the merger of two remnants, the flare of a dying whole. Awareness, if it exists, would need to sleep for ages and wake for moments. The unit of a day would lose its meaning. The universe becomes a place of long patience. We are nearing the end of gravity's rule. When the last black hole breathes out its final light, there will be no engines left to concentrate matter, no furnaces to make new stars, no deep wells to gather what is left. The next chapter is not loud. It is subtle. It is the dark era, a time of thin light, quiet particles, and a temperature sliding ever closer to absolute zero. Before we enter that winter, take one last look at the giants. They were the keepers of structure, the archivists of galactic history, and the authors of the universe's final fireworks. Even they cannot last forever. When their glow fades, the stage remains, but almost everything on it has exited. We will step onto that bare stage next and listen for the quietest sounds the cosmos can make. Step into the dark era. The last black holes have given their final sighs of light. The stage remains, but almost all the props are gone. What fills the universe now is a thin, cold mist of the simplest things: faint light, ghostly particles, and space itself. In the young universe, change came from differences. Hot met cold, dense met thin. Stars formed in pockets of gas, gravity pulled, fusion burned, and light flowed from bright places to dark ones. In the dark era, those differences fade. Temperatures even out. The background light is stretched to waves so long they are closer to a rhythm than a color. The universe has slid toward balance, what physics calls maximum entropy. In plain words, the energy is too evenly spread to do much work. Without hills and valleys in the energy landscape, nothing large can roll. That does not mean nothing exists. It means existence is quiet. Photons, the particles of light, still cross the void, but they are soft and stretched. Neutrinos, shy particles that barely notice matter, still outnumber everything else by far. If protons decay, then over unimaginable spans, the heavier pieces of matter slowly melt into lighter particles and radiation. If protons do not decay, then some cold remnants persist, but they are thin on the ground and thinner every age as expansion keeps opening the map. Expansion matters even now. Long ago, nearby galaxies drifted away. Later, only our local island remained. In this era, even that neighborhood has thinned and dispersed. Distant horizons harden. Most of the universe becomes permanently out of reach, not by walls, but by speed. Space between far places stretches faster than any traveler can cross. Communication shrinks to the small and near, and then to almost nothing at all. What is left to happen in such a world? Slow, rare things. Radioactive elements, buried in ancient rocks, if any rocks remain, continue to tick down. The slow glow of leftover heat leaks into space. Particles meet by chance and drift apart again. The average day, measured in local events, is calm. Yet the universe still keeps a faint heartbeat. Even empty-looking space is not perfectly still. Quantum rules allow tiny, brief fluctuations, pairs of particles that appear and vanish too quickly to see. Most of these flickers cancel out and leave no mark, but over times this vast, the unlikely can become the occasional. Think of rolling dice with patient, infinite hands. Most rolls are nothing. Once in a great while, a rare pattern appears. One rare possibility that physics whispers about is a change in the vacuum itself. The vacuum is not nothing. It is the stage with specific rules. If our current vacuum is not the true lowest state, then a truer state could someday appear in a small bubble and expand at nearly the speed of light. Inside the bubble, the laws of physics could be different, new constants, new particles, perhaps no chemistry as we know it. This is called vacuum decay. We do not know if it can happen. We do not know when. If it does, there is no warning and no pain. The bubble front would outpace any signal. In a sense, it would be a clean page turned all at once. Another whisper is even stranger, the idea of spontaneous order from random noise. Given enough time, a handful of particles might, by pure accident, arrange into something like a molecule or a tiny machine, or a brief mind, a so-called Boltzmann brain. The odds are absurdly low. But eternity is long. If the dark era truly lasts without end, the total count of rare events might not be zero. This sounds like philosophy wearing physics coat, perhaps at Island. It reminds us that our intuitions were built in a world of days and seasons, not in a sea of aeons. Between such far speculations, there is a simpler picture, a universe that keeps cooling, keeps expanding, and keeps smoothing out. Space has a temperature set by its horizon and its faint bath of radiation. That temperature drifts towards zero, but never quite arrives. Absolute zero is a line the universe approaches forever, like a boat that points at the North Star and sails, yet the star stays at the same distant angle. What does time mean here? In the age of stars, we measured time by cycles, dawn to dusk, spring to winter, orbit to orbit. In the dark era, cycles are scarce. Time becomes the count of rare events between vast quiet. A year loses meaning. A million years is a short nap. Awareness, if it persists in any form, must stretch its patience to match the world. And yet, meaning can live even in quiet. Think of a lake at night after the wind has died. The surface is flat, the air cold, the sounds small. If a fish turns, you notice. If a meteor streaks, you remember. The lake is not boring. It is precise. The dark era is like that. Every slight ripple matters because the rest is still. Could this be the end of the story? Possibly. A universe smoothed to calm, with no engines left to restart the bright age. That is one honest ending. Heat death is not a crash or a bang. It is a gentle settling, like embers going from orange to black. In that ending, the timeline does not stop. It becomes a long, level line with tiny, rare specks. But physics keeps a cabinet of alternative endings. If dark energy strengthens with time, space could not only expand but tear itself apart. The Big Rip pulling apart galaxies, then stars, then atoms, and finally even the fabric that binds particles. If, instead, dark energy fades or changes sign, gravity could someday win again on the biggest scales, turning expansion into contraction, a long, slow, big crunch. Or perhaps there is a bounce, a collapse that triggers a new burst of expansion, resetting the stage. Perhaps what we call our universe is one bubble in a larger foam, and new bubbles form elsewhere, forever. We do not know which cabinet holds the truth. We know enough to sketch the quiet, and we are humble about the rest. The honest voice says, here is what the math suggests today. Here is where it admits mystery. The universe has surprised us before. So we pause at the edge of the dark era and look out. The scene is spare, the colors muted, the motions few. But we have walked the river from bright noon to this midnight, and the journey has given the night its meaning. In the next chapter, we will open those alternative endings and walk each one by one, not to predict, but to imagine clearly, and to feel how each would change the last page of time. Open the cabinet of endings and take each path in turn. We will walk softly, because this is bedtime science, the kind that lets your mind drift without getting tangled. Each path is a sketch, not a verdict. Physics is our map. Humility is our compass. The first path is the quiet one we already met. Heat, death. Over vast ages, energy spreads until there are no useful differences left. No steep hills of heat to roll downhill, no cold valleys to fill. The universe becomes an even, thin mist of faint light and shy particles. Changes still happen, but they are sparse and small. Time feels like a long, level field under a winter sky. Many astronomers treat this as the default ending if dark energy keeps behaving as it does today. The second path is the Big Rip. Imagine dark energy not as a steady push, but as a push that strengthens with time. Galaxies drift apart faster, then much faster. The fabric of space stretches like a drumhead pulled tighter and tighter. In the late stages, even the gravity that binds galaxies, then stars, then planets, and finally atoms cannot keep up. Structures unfasten, scale by scale. No explosion, just a smooth, unstoppable untying. If the rip sits far in the future, the sky looks calm for a long time. Then, near the end, everything unthreads at once. The third path is the big crunch. Here, dark energy fades or flips. The universe's expansion slows, pauses, and reverses. From that moment on, what was drifting apart begins to fall together. Over ages, the night brightens as distant light is no longer stretched red but squeezed blue. Galaxies reapproach. Background radiation warms. The sky that once thinned now thickens. At the end, all matter, all light, all space crowd into a hot, dense state, the mirror of the beginning. This would not be a rewind, but a different closing verse written in the same key. The fourth path is the bounce. A crunch does not have to be a wall. It can be a spring. In several models, extreme compression triggers a rebound, a fresh expansion, a new cosmic morning. The new round may not remember the old. Laws and constants could reset. The menu of particles might change, or faint fingerprints could pass through, like a rhythm echoed through a wall. Subtle patterns in the new sky hinting at an earlier verse. Teams have searched the cosmic microwave background for such clues. None are confirmed. The fifth path is the foam, the multiverse picture. In this view, our visible universe is one bubble in a larger sea. Space inflates rapidly in many places at once, and bubbles form where inflation ends. Each bubble has its own local rules, its own recipe of particle masses and forces. Most bubbles never touch. Now and then, two might bump, leaving circles or scars in the microwave afterglow. We have looked. Nothing decisive has appeared. Still, the math behind inflation fits early universe data well, which is why many researchers keep the foam idea on the table. The sixth path is the vacuum flip. If our vacuum is a perched state rather than the deepest valley, quantum chance could spawn a tiny bubble of a truer vacuum. It would expand at nearly light speed, rewriting the laws as it goes. No alarm, no countdown, just a change of stage. From the inside, it might look like a new universe with new rules. From the outside, there is no outside left. Most physicists treat this as a remote possibility, not a plan. If it is possible at all, the time scale is so long that no clock we know could measure it. The seventh path is recurrence, a poet's path made of math. In a truly finite sealed system left alone long enough, the random jostling of parts will, with absurd rarity, stumble into familiar arrangements. Dice roll into yesterday's pattern. Molecules replay an old dance. Perhaps, in thought experiments, a Boltzmann brain blinks into awareness for a heartbeat before dissolving. This is less a forecast than a caution about infinity. When time is endless, the wildly unlikely is not the same as impossible. Which path will reality choose? Our best evidence today favors the quiet one: continued expansion, cooling, and a slide toward heat death. The rip needs a dark energy that strengthens. The crunch needs it to fade or reverse. The bounce and foam ask for deeper layers of the early universe engine. The vacuum flip depends on what lies under the floorboards of our physics. Missions now, and planned mapping galaxies, weighing weak lensing, timing supernovas, are lanterns held up to one question: what exactly is dark energy? Yet notice what all paths teach in the present. The universe is dynamic, generous with time, and not obliged to our preferences. We are lucky, listeners placed in a luminous movement, and that makes our moment rare. Knowing how the song might end is not a cause for dread. It is an invitation to savor today's notes. Stand once more at the balcony of now. Outside, one star warms one world. The air carries ocean salt and pine resin. Somewhere, a telescope tucks another faint galaxy onto a map. Somewhere else, a child looks up and asks, "How far does it go?" The honest answer is long and layered, but the simple answer is this: far enough that wonder never runs out. In the next chapter, we will turn from endings to the quiet rules that guided every chapter, the building blocks that let time have a shape at all, and we will tell them in the simplest language we can. Draw the curtain back and look at the quiet rules that guided every chapter. We will keep the language plain, because these rules are simple at heart, even when their math is not. Think of them as the grammar of reality, the habits the universe never forgets. Rule 1: time is change. A clock is anything that repeats. Your pulse, Earth's spin, an atom's tiny vibration each marks steps. Stretch the steps to cover billions of years and the idea stays. When nothing changes, time has no story. That is why the far future feels like a hush. Rule 2. Nothing outruns light. Light's speed is a limit, not a suggestion. It is the fastest way to send cause to effect. This limit ties space to time. Move through one, and you move through the other. Near light speed, lengths shrink and time dilates. The message is simple. Events cannot call each other faster than this speed. Rule 3. Gravity is curved space. Mass and energy tell space how to curve. Curved space tells matter how to move. Drop a ball and it falls not because a thread pulls down, but because the straightest path in curved space aims inward. Around black holes, the paths all point deeper. Curvature keeps the dance. Rule 4. Energy spreads unless held. Hot coffee cools. A neat room gets messy. Stars use concentrated fuel and end as diffuse light and ash. This is entropy, the count of ways a system can be arranged. More ways means higher entropy. The arrow of time we feel is this one-way drift from tidy to mixed. Life pushes back locally by taking in energy and exporting disorder. Rule 5. The small world is grainy and uncertain. Quantum rules say you cannot pin down both a particle's position and momentum perfectly. Particles are also ripples in fields that fill space. When we see an electron or a photon, we are noticing a field quiver that briefly stands out. Chance is baked in, yet averaged over many events. The odds make reliable patterns. Rule 6. Forces come in a few kinds. Electromagnetism shapes light, atoms, chemistry, and nerves. The strong force glues atomic cores. The weak force allows certain decays and starts the sun's subtle first steps. Gravity shapes the large-scale map. The first three are carried by exchange particles. Gravity may be 2, though we have not caught its messenger. Rule 7. Symmetry writes laws. When a system looks the same, under certain changes, shift in time, move in space, rotate conservation laws appear. Energy, momentum, angular momentum. These are bookkeepers that never lose track because the background is even. This link sits quietly under rockets and red giants alike. Rule 8. On large scales, the universe looks the same in every direction and from any place. This cosmological principle lets us treat the whole as a smooth fluid. From that, general relativity predicts expanding space. Distances grow like the surface of a rising loaf, with no center on the crust. Light from far galaxies stretches into red. The amount of stretch tells their speed and distance. Surveys and missions such as Hubble, WMAP, and Planck refined this picture. Rule 9. Most of the gravitating stuff is invisible. Galaxies spin too fast at their edges for visible stars to hold them together. Clusters bend background light more than bright matter alone can explain. We call the missing mass dark matter. It acts like a clear, cold scaffold. We do not yet know its particle, only its pull. Rule 10. Empty space has energy. In our equations, it behaves like a pressure that does not thin as space grows. This effect, nicknamed dark energy, makes expansion speed up. We infer it from supernova surveys, galaxy maps, and the hush of the microwave background. What it is remains open. Rule 11. Information matters. Black holes taught us that. They have temperature and entropy. When they evaporate, their final glow must carry, in scrambled form, the record of what fell in, or else physics would lose its ledger. This information paradox nudges gravity and quantum theory to meet. The talk is not finished, but it hints that space, time, and information are braided tightly. Rule 12. Scales talk. The very small sets the menu for the very large. A tiny imbalance in the early plasma, slightly more matter than antimatter, made later atoms possible. A faint ripple spectrum seeded galaxies. Neutrinos, though shy, nudge how structures grow. This is why precision studies of tiny things change our picture of the cosmos. and why mapping the sky teaches us about particles we barely catch on Earth. Keep these rules in your pocket. They explain why stars shine and die, why black holes are simple and strange, why time has a direction, and why the far future grows quiet. They also explain why the present is rich, free energy flows, contrasts abound, and the universe is young enough to be busy. In the next chapter, we will bring the rules back to the human scale. We will speak of meaning without math, how to live in a cosmos that is vast, old, and cooling, and how knowledge of endings can deepen the small hours of our day. Bring the rules back to the human scale. Stand in your kitchen at night, the refrigerator hums. Streetlight slips through the blinds. On the counter sits a glass of water, catching a faint glow. Your heart keeps time, your breath sets the tempo, and outside, a planet turns under 1 billion stars. The vastness is here with you, not to drown you but to make the small clear. Meaning begins with attention. In a universe where entropy rises, order is precious. Every tidy room, mended shirt, and planted seed is a small act against drift. Life does not defeat entropy. It borrows pockets of low-entropy sunlight, food, stored energy, and turns them into pattern and story. Breakfast is cosmology in a bowl. You take energy concentrated by a star and convert it into thought, motion, and care. Seen this way, gratitude is practical. Humility fits well here. We are small, yet we live in the slice of time that glows. The age of stars is our neighborhood. We have beaches, thunderstorms, ripe figs, jazz, and children who fall asleep on car rides. We can measure galaxies and still misplace our keys. The scale is not an insult, it is a gift. Because we are small, we can love a few people deeply. Because our lives are brief, choices matter. The cosmic view is not meant to float us away. It is meant to root us. When you think about the sun's long arc or the chill of the dark era, the coffee in your hand becomes warmer. The morning becomes specific. You notice a recipe in your grandmother's hand. You text a friend back. You pick up a piece of trash the wind pushed against a fence. The end of time is not an excuse to drift. It is a reason to lean in. Stewardship is a natural answer. Earth is a rare oasis in a dry universe. Water runs, air moves, life invents shapes. To care for it is not a slogan. It is a survival habit and a form of art. Plant trees whose shade you will not sit in. Learn names of birds, of rocks, of neighbors. The more names you know, the richer the world becomes. Patience is another answer. Stars take their time, so can we. The habits that build a life: reading, saving a little, practicing a craft, making amends, work on timescales longer than a mood. When you are restless, step outside at night. Find one star. Let its light, older than your city, land on your face. Breathe once for yourself, once for someone you love, once for someone you do not know. Call it a reset. Curiosity is fuel. We thrive when we ask, then follow the question with a walk, a book, a conversation, an experiment. You do not need a telescope to think like a scientist. You need a willingness to be wrong, to change your mind, and to keep notes. Carry a small notebook. Write 3 things you notice each day: a smell, a sound, a shape. Over weeks, you will have a map of your life no algorithm could predict. Connection keeps the lights on. In the far future, the cosmos goes quiet. In the near present, you can make noise that matters. Laughter at a table, a song shared, a story told to a child who will carry it. These are low-tech ways to outlast a lifespan. Languages braid forward when we teach. Perspective eases anxiety. When your thoughts race, picture the timeline we've walked. Put your worry on it like a pin. Now step back until continents blur and the pin shrinks. The problem does not vanish. It right-sizes. This is not denial. It is calibration. Then do the next right thing. Craft something. Bake bread. Fix a hinge. Draw a map of your block from memory. Send a letter in your own hand. Make a playlist for a friend who cannot sleep. These acts turn free energy into shape and comfort. They teach your hands that they live in a world they can influence. Keep a list of long projects, plant an orchard, learn a language, scan old photos, record elders' stories, mentor someone younger. Long projects are bridges across time. They pay interest to futures you may never visit. Practice mercy. If the universe trends toward evenness, stinginess is redundant. Be generous with praise, apology, and attention. The return is practical. Relationships are our best technology for weather and change. Sleep belongs in the plan. Dreams are the brain's nightly housekeeping entropy management for memory and mood. Make bedtime gentle. Dim lights, cool room, a book that does not shout. Step outside for one last look at the sky if you can. Tell the day, thank you. That will do. Then, let go. Hold two truths without conflict. First, in the longest view, everything settles. Second, within our span, life teems with meaning. You can honor both by tending what is near, while admiring what is far. Use the stars, not as escape, but as a frame. One last practice. Adopt an era. Maybe you love the newborn universe, a hot fog learning to become transparent. Maybe you love the red dwarf winter, with quiet worlds around tiny suns. Maybe you love the last fireworks of evaporating black holes. Read about your era, draw it, write a page in its voice. Then the timeline becomes a place you have visited, not just a chart you were shown. Stand again in your kitchen. The refrigerator hums. The glass of water shines faintly. Somewhere a satellite crosses a dark field. Somewhere a child counts seconds between lightning and thunder. We are inside the bright movement now. That is enough to make a life. In the next chapter, we will return to the long river and pick up its tempo again, gliding farther into futures that stretch past language, and then circling home for a gentle landing. Raise the shutter speed of imagination and let the frames fly. Our time-lapse accelerates until centuries flicker like candle flames and whole galaxies breathe in and out between blinks. We are gliding past signposts with names too large for the tongue numbers, with more zeros than snowflakes in all the winters that ever were. Stay calm. We will keep our feet on simple ground, even while the sky rushes. Set a new scale. If 1 second were a year, a human lifetime would be 2 minutes, history an hour, dinosaurs 5 days ago, the sun's life 3 centuries. 1 trillion years would be 30,000 years on this clock older than cities. The eras ahead need bigger clocks still. We pass the long winter of red dwarfs as if watching coals dim in a stove that never runs out of night. White dwarfs cool to black dwarfs cold to cinder. The archive of remnants thins as orbits drift. In old galactic centers, the last meals feed the last black holes. Their final sighs of hawking glow sketch soft halos that fade like fireflies in autumn. Now the universe is a sparse cathedral. The air is cold, aisles are wide, footsteps are rare, photons stretch until they are more rhythm than color. Neutrinos pass like a breeze you cannot feel. Space expands without hurry. Here is a gentle puzzle. Can thinking survive when the lights are low? Some imagine strategies for minds in a thinning world, slow thoughts so each idea takes longer, using less energy per moment. Sleep for eons, wake for instants. Reversible computing logic that wastes almost no heat might stretch each spark of energy farther. None of this breaks physics. All of it demands engineering we cannot promise. But it says something tender. That curiosity, given a crack of energy, will try to bloom, build where heat still leaks, rogue planets with warm cores beneath thick ice, habitats wrapped in the faint drizzle from dwarf remnants, machines sipping tiny gradients the way moss drinks dew. The universe does not forbid these niches, it simply prices them in patience. Count forward again. The last dwarf pairs flare, then sleep. The last black holes fade with a final spark. If protons decay, the last knots of matter relax into simpler particles. If they do not, cold cinders endure, scattered like lost beads on a carpet that keeps stretching. In both versions, structure drains toward plainness. The arrow of time, once a wind at our backs, becomes a fog that softens edges. What remains to notice? Every rare coincidence. 2 particles meeting after a voyage, the size of 1,000 galaxies. A lone decay that brightens a cubic light-year by a whisper. A fluctuation that, for a breath, sketches a tiny ring before it falls apart. In a busy world, such blips would be noise. In this quiet, they are the whole song. If the vacuum is perfectly stable, there is no trapdoor. If it is not, a bubble of a truer vacuum may appear without warning and rush outward at almost light speed. It would not feel like destruction from the inside. It would feel like different rules, a new book opened in the same library. We cannot plan around this, we can only note the footnote. There is another footnote, recurrence. In settings, with limited ingredients and endless time, chance can stack the same cards again, not often, not on any schedule. But given long enough, unlikely things stop being never. Infinity is not a human-sized room. The safe summary is this: eternity is weird. We have now drifted beyond the range where language keeps its edges. Our time-lapse becomes more mood than map. The frame holds mostly darkness and faint specks. The soundtrack is a long, fading chord. If we kept going, the changes we would mark fit on a single line across an empty page. It is not that the story stops, but that the letters grow too small for comfort. So we begin to circle home. On the way back, the present brightens. As motion slows, details return. Arcs of galaxies, foamy clusters, curls of star-forming clouds. Slow more, and you see pencil marks on the margins of history. Stone tools, bread ovens, lullabies. The camera that stared into forever turns to our doorstep. The key is under the mat. A pot of soup fogs the window. Somewhere, rain starts. A final exercise for scale. Hold out your hand. On your fingertip, in a raindrop, lives a scene that would have been invisible from the end of time. Bacteria swimming, proteins folding, a spark leaping along a neuron that decides to smile. The power we sought in quasars and black holes also runs here, in quiet forms. The same rules that dimmed the universe made a brain that can notice the dimming. We have not wasted our ride. Our species learned enough rules to sketch shorelines of the future, and enough humility to admit blank spaces. We named eras, mapped fates, and still found room for poems. We learned that endings can be soft, and that meaning does not need forever, it needs attention. As our time-lapse settles to normal speed, listen to the ordinary rooms of the world. A kettle sings, a cat turns 3 circles and sleeps. Somewhere a rocket's second stage cuts off, and a satellite wakes. Somewhere else, a nurse adjusts a blanket and a patient rests. The universe does not divide these scenes from the grand ones. They share one physics and one timeline. We will land soon, then walk slowly through the last chapters, returning to the birth of light, tying the far future to the first morning, and leaving you with a calm that can carry you into sleep. The river of time is vast, but the water in your glass is part of it. Sip, and you are connected to everything we have seen. When you are ready, set the cup down. We will touch the beginning next, and then close the circle. Touch the beginning, roll the film backward until stars melt, galaxies unweave, and night turns to a warm fog. Keep going. Structures shrink to ripples, ripples smooth to bright silence. We arrive at a time when the universe was smaller than a grain of dust, and hotter than any furnace, a newborn so swift and dense that ordinary words slip. In that first instant, space and time themselves were being written. Picture a blank page appearing letter by letter, except the letters are the rules of physics. Energy was packed tight. Everything flickered. Nothing held still long enough to have a name. Then, in a breath beyond measure, the universe swelled. This is inflation. Not things racing through space, but space itself, stretching, like dough rising in an oven. A tiny, quantum rough patch became vast and smooth. As the expansion eased, the newborn cooled from the unimaginable to the merely extreme. The first ingredients, quarks and gluons, splashed through a hot soup. Soon they teamed into protons and neutrons. Within minutes, the universe tried its first recipe, fusing some of those protons and neutrons into light nuclei. Most became hydrogen, a smaller share helium, and a trace lithium. Heavy elements had to wait for stars. For hundreds of thousands of years after that, the universe was too hot and crowded for atoms to hold together. Electrons were knocked loose as soon as they tried to settle. The whole cosmos was a glowing fog that trapped light. As it kept expanding and cooling, a tipping point arrived. Electrons finally found steady seats around nuclei. The fog cleared. Light could travel freely. That first free light still bathes space today as a faint microwave afterglow, the oldest photograph in existence. The ages between the clearing of the fog and the birth of the first stars were swaths of dark. Gas fell slowly along, invisible scaffolding laid down by dark matter. Gravity, patient as always, gathered clouds. Where clouds grew heavy, they collapsed, heated, and lit. The truly first stars were likely huge and brief blue-white furnaces that lived fast, forged heavy elements in their cores, and ended as titanic blasts. In those deaths, the universe made carbon for cells, oxygen for water, calcium for bones, and iron for blood. With starfire came a second dawn. Ultraviolet light from early stars and newborn black holes peeled electrons off atoms again, turning the intergalactic gas from neutral back to ionized. We call this reionization, a long word for a simple picture. Bright bubbles ate away at the dark until the cosmos was transparent and lively. Galaxies thickened along filaments like dew on spider silk. The cosmic web, the grand, foam-like pattern, grew clear. Over billions of years, small galaxies merged into larger ones, and larger ones kept rearranging. Disks spun up, somewhere in a modest spiral that would one day be called the Milky Way. A cloud dwindled into a spinning plate with a bright knob. At the center, the sun ignited. In the dust around it, bits collided and stuck. Pebbles became boulders, boulders became worlds. One world settled at a gentle distance where liquid water could linger. A glancing impact likely birthed the moon. Rain fell for ages. Oceans took their basins. Lightning and sunlight toyed with simple molecules. And chemistry learned a new trick to make copies of itself. Life did not arrive as a leap, but as a step that found purchase, and then took another. Microbes ruled the calendar for nearly all the pages that followed. They breathed rocks and light, traded genes, and filled the air with oxygen. The sky changed, new engines became possible. Later, multicellular bodies explored new plans: shells, fins, leaves, feathers, and flowers. On one branch, hands learned to shape tools that could shape other tools. Fire moved from lightning to hearth. Stories moved from mouth to clay to fiber to electric pulses. Eyes extended by lenses looked back at the sky that had made them. We found the afterglow of the first light, measured the speeds of distant galaxies, weighed the missing mass, and gave simple names to deep wonders. It is easy to make the beginning sound like a bang and the rest like aftermath. A better picture is a long breath. Expansion is the exhale. Gravity is the gentle inhale that makes pockets dense. Fusion is the warmth of metabolism. Supernovas are the seeds cast to the wind. The universe gardens itself. We are one flower that learned to think. Notice how the beginning admits the end. The same rules that let light roam after the fog also let light stretch and thin. The same gravity that built galaxies also fed black holes. The same flow of energy that lit stars also raised entropy. The laws are consistent. That is their kindness. Because they are consistent, we can sketch the far future without having been there. Because they are kind, breakfast still tastes good. Within minutes, the universe tried its first recipe, fusing some of those protons and neutrons into light nuclei. Most became hydrogen, a smaller share helium, and a trace lithium. Heavy elements had to wait for stars. For hundreds of thousands of years after that, the universe was too hot and crowded for atoms to hold together. Electrons were knocked loose as soon as they tried to settle. The whole cosmos was a glowing fog that trapped light. As it kept expanding and cooling, a tipping point arrived. Electrons finally found steady seats around nuclei. The fog cleared. Light could travel freely. That first free light still bathes space today as a faint microwave afterglow, the oldest photograph in existence. The ages between the clearing of the fog and the birth of the first stars were swaths of dark. Gas fell slowly along, invisible scaffolding laid down by dark matter. Gravity, patient as always, gathered clouds. Where clouds grew heavy, they collapsed, heated, and lit. The truly first stars were likely huge and brief blue-white furnaces that lived fast, forged heavy elements in their cores, and ended as titanic blasts. In those deaths, the universe made carbon for cells, oxygen for water, calcium for bones, and iron for blood. With starfire came a second dawn. Ultraviolet light from early stars and newborn black holes peeled electrons off atoms again, turning the intergalactic gas from neutral back to ionized. We call this reionization, a long word for a simple picture. Bright bubbles ate away at the dark until the cosmos was transparent and lively. Galaxies thickened along filaments like dew on spider silk. The cosmic web, the grand, foam-like pattern grew clear. Over billions of years, small galaxies merged into larger ones, and larger ones kept rearranging. Disks spun up, somewhere in a modest spiral that would one day be called the Milky Way. A cloud dwindled into a spinning plate with a bright knob. At the center, the sun ignited. In the dust around it, bits collided and stuck. Pebbles became boulders, boulders became worlds. One world settled at a gentle distance where liquid water could linger. A glancing impact likely birthed the moon. Rain fell for ages. Oceans took their basins. Lightning and sunlight toyed with simple molecules. And chemistry learned a new trick to make copies of itself. Life did not arrive as a leap, but as a step that found purchase, and then took another. Microbes ruled the calendar for nearly all the pages that followed. They breathed rocks and light, traded genes, and filled the air with oxygen. The sky changed. New engines became possible. Later, multicellular bodies explored new plans. Shells, fins, leaves, feathers, and flowers. On one branch, hands learned to shape tools that could shape other tools. Fire moved from lightning to hearth. Stories moved from mouth to clay to fiber to electric pulses. Eyes extended by lenses looked back at the sky that had made them. We found the afterglow of the first light, measured the speeds of distant galaxies, weighed the missing mass, and gave simple names to deep wonders. It is easy to make the beginning sound like a bang and the rest like aftermath. A better picture is a long breath. Expansion is the exhale. Gravity is the gentle inhale that makes pockets dense. Fusion is the warmth of metabolism. Supernovas are the seeds cast to the wind. The universe gardens itself. We are one flower that learned to think. Notice how the beginning admits the end. The same rules that let light roam after the fog also let light stretch and thin. The same gravity that built galaxies also fed black holes. The same flow of energy that lit stars also raised entropy. The laws are consistent. That is their kindness. Because they are consistent, we can sketch the far future without having been there. Because they are kind, breakfast still tastes good. Midday in the cosmic year is generous. Blue worlds circle steady stars. Nebulas glow around nurseries. Contrast abounds. Hot and cold, bright and dark, full and empty. Free energy flows downhill and writes complexity on its way. Forests trade light for sugar. Brains trade sugar for thought. Radios turn thought back into light and send it outward across the night. Late afternoon approaches the way all afternoons do. The brightest, fastest stars finish first. The sun will last, then drift into evening and shed its outer layers as a thin, glowing shell. Its heart will cool as a white dwarf, small as a planet, dense as a memory. Across the larger city of stars, formation slows. Fireworks are rarer. Rogue worlds wander, warm from within, under blankets of ice. The universe still has sparks, but the pauses between them grow long. Evening deepens. The age of remnants begins. White dwarfs dim toward black dwarfs, black in color but not in story. Neutron stars persist as tiny anvils. At galactic centers, black holes keep the archives and ring their bells when a stray star falls in. Expansion stretches the map so gently you would not notice in a lifetime, but across eras, it reshapes the knowable sky. More and more is far for good. Night comes as a slow settling, not a switch. If protons decay, matter loosens into lighter notes. If they do not, cold cinders survive, thinned like lone houses on a plain. Black holes leak their last heat with a final sparkle. After that, the main sound is the soft shuffle of low-energy light and shy particles that slip between everything. The temperature of space drifts toward zero, like breath fading on a pane. There may be footnotes. Dark energy could strengthen and untie everything the Big Rip. It could weaken and let gravity pull the curtain back. The big crunch. A crunch could bounce, the vacuum could flip, or the quiet could simply continue. The map allows these paths. Today's road points most strongly toward the soft one. Circle back to the lantern on the bank. Home is still here, lit by a middle-aged star. Air moves, water shines, people build, and music finds harmonies that feel like physics turned into sound. None of this cancels the larger arc. All of it lives inside it. The rules that will one day dim the galaxies also make bread rise. Lenses focus, and hearts keep time. Because the rules are steady, we can plan a garden and aim a telescope. Because time has a direction, choices have weight. Hold that comfort. You are not required to solve the universe to be at ease in it. Let the long story be long. Set a pot to simmer, open a window, and hear a small rain that began as vapor lifted by sunlight, that began as fusion deep in a star, that began as dust from a star that ended before our planet was born. That line is not a burden, it is a thread. Now let the arc fade toward quiet. The film slows. The bright rooms of history soften. The river widens and loses its rush. Somewhere in the dark, a tiny flare still rises now and then, and someone notices. Then the water smooths again. The night is not an enemy. It is a rest that belongs to a day well lived. The lantern on the bank burns low, but it is enough to see by. This is the story in one piece. A warm beginning, a bright middle, a gentle end, and a home that sits content between them. Keep it as a picture you can visit when you lie down and the house grows quiet. The river will keep flowing whether we watch or sleep. It always has, and that is good. Open a quiet drawer of the universe and lay out postcards from different ages. Each card holds one scene, one sound, and one simple truth. Read them slowly, like counting breaths before sleep. Postcard 1. The first light. The fog lifts and the cosmos takes its first clear photograph. That afterglow still whispers across space as a cool microwave hush. We built ears to hear its satellites like Kobe, WMAP and Planck, and from that whisper we learned the universe is flat enough to skate on and expanding like a loaf in the oven. A lesson. Even very old light can tell a fresh story. Postcard 2. The first stars. Dark matter sketches, scaffolds, gas gathers, fuses, shines. These giants are brief and blue, living fast and seeding space with heavy elements. When they die, they leave instructions for chemistry. Make water, make rock, make carbon chains that curl into life's first ladders. A lesson. Endings plant beginnings. Postcard 3. A spiral called the Milky Way. Arms wind like slow rivers, dust lanes veil, cradles where new suns ignite. At the center sleeps a black hole, quiet until lunch is served. We learned its weight by watching stars orbit an invisible point-patient astronomy with a ruler made of time. A lesson. You can weigh what you cannot see by how it makes other things move. Postcard 4. One yellow star and a blue bead. Gravity flattens a cloud to a record. In its grooves form worlds, each an experiment. One sits just right for liquid water. A glancing blow makes a moon that steadies the bead's tilt, and tides become a soft metronome. A lesson. Balance is not an accident. It is a long negotiation. Postcard 5. rain and recipe, oceans cool, minerals dissolve, lightning cracks, and simple molecules dance. Some learn to copy with small mistakes. The mistakes are notes that evolution plays. For nearly all of Earth's calendar, life is single-celled and successful. A lesson: greatness can be tiny and slow. Postcard 6. Breath that changes the sky. Microbes exhale oxygen, iron rusts. The air sweetens for engines that burn clean. Later, bodies learn to share the work. Eyes watch, fins push, leaves harvest light. A lesson: cooperation is a technology older than tools. Postcard 7. Hands that remember. Fire moves from storms to hearths. Language turns air into memory. Lenses multiply sight. With radio, we give thought back to light and send it outward. NASA, ESA, and many others add images to the family album. Earthrise from lunar orbit. The pillars of creation. A black hole's shadow traced by a planet-wide net of dishes. A lesson: curiosity scales. Postcard 8. The slow migration of continents. Plates drift on a mantle's crawl. Mountains rise, wash down, rise again. Rivers rind stone to sand, sand to beaches where someone will one day stand with a child and point out a bright planet at dusk. A lesson: the map is alive. Postcard 9. The quiet calendar of the sky. Constellations drift, the North Star changes. Comets return on leashes of centuries. Eclipses repeat in Saro's families, reliable as tides. You can set your emotions against this pace and feel them settle. A lesson: rhythms larger than us can carry us. Postcard 10. The sun's evening. Hydrogen thins, the core tightens, the outer layers puff to copper. Mercury and Venus vanish into the glow. Earth's fate is a trio of maybes, all without seas. The sun sighs a nebula and keeps its hot heart as a white dwarf. A lesson: even giants retire. Postcard 11. The red dwarf winter. Tiny stars sip fuel for trillions of years. They're close-in planets where rings of permanent dusk, where life might stroll under a ruby sky. Flares calm with age. Patience becomes the climate. A lesson: long-lived does not mean dull. Postcard 12. The archive era. Galaxies fade to libraries of remnants. White dwarfs cool. Neutron stars persist. Black holes collect and slowly leak. Expansion carries far islands out of reach. A lesson: some doors close not by choice, but by distance. Postcard 13. The quiet field. The universe spreads its energy thin. Heat death is not a cliff. It is a level meadow under cold stars that no longer burn. Rare sparks still appear faint, brief, precious. A lesson: in silence, small sounds matter more. Postcard 14. Alternate endings. Rip, crunch, bounce, flip, foam, the cabinet of maybes. We hold them lightly, check the sky, and let measurements lead. A lesson: confidence grows from tests, not from volume. Postcard 15. Home again. A lamp in a window, a kettle's hum, a child's yawn. Outside, Orion is rising. Inside, someone rinses a cup and sets it to dry. The long story does not ask us to be more than this. It asks us to notice that this belongs to the story. A lesson, meaning lives where attention rests. Lay the postcards back in the drawer. The universe keeps the originals. We keep the copies in our minds. If you want, choose one to dream on tonight. The first light, the red dwarf winter, or the last black hole's spark. When you wake, you can add one more card. Today's small kindness, filed under local miracles. In the next chapter, we will turn the time-lapse dial one last time, giving you a closing pass from sunrise to starlight, to silence simple, slow, and shaped for sleep. Begin at a quiet dawn. The fog of the newborn universe thins, and light walks free for the first time. Atoms take their seats, the stage cools, the lights dim to stars. The opening feels simple because simple is all that can survive there. Hydrogen, helium, a trace of lithium. Gravity leans close and whispers, "Gather." Gas collects, falls, heats, and ignites. Campfires the size of cities, then continents, then clusters, blaze in the dark. Follow one strand. A giant star lives fast, fuses deep, and ends in a bright farewell that throws heavy elements outward. Those grains drift like golden pollen. They seed clouds that flatten to disks, where pebbles bump, cling, and grow into worlds. Around one modest star, a blue planet cools enough to hold oceans. The moon steadies its tilt, tides keep time, lightning and sunlight coach chemistry into trying ideas that can copy themselves. Now lift to the wide shot. Galaxies braid into a web. Filaments glow at their crossings. Black holes nap at their centers and wake for meals. Between islands of light, space stretches, wavelengths grow long. The map enlarges with every beat. The young cosmos is a busy city. Nebulas bloom, clusters fly apart, and supernovas write calcium for bones and iron for blood. Pause at the porch light called home. Air moves, water shines. A child asks for one more story. Eyes, helped by glass and radio, look out and discover a family portrait older than any kingdom. The microwave afterglow, faint and even, with tiny wrinkles that foretold where galaxies would grow. The message on that portrait is steady. The rules are reliable. The future is calculable in outline, even if the details surprise. Roll the frames forward. The brightest stars bow out first. The sun takes its time, keeps a steady chord, and then enters a copper evening. It sighs a soft shell, keeps its white-hot heart as a dwarf, and cools with patience. Red dwarfs hum for trillions of years, soft coals in a deep stove. Their close worlds may carry a ring of permanent dusk, where winds run from hot to cold, and the sky is ruby. Drift farther, galaxies thin to libraries. White dwarfs dim toward black. Neutron stars sit like iron thimbles. Black holes curate the archives and leak a slow, cold glow. Expansion turns far places into forever away. The cosmic weather forecast calls for long, clear nights with rare flares. Now slow the frames until the sound becomes a hum. The dark era is not a cliff, it is a meadow after snow. Energy is spread thin, work is hard to find, rare events are precious. If the vacuum is stable, quiet lasts. If it flips, the stage changes without warning. If dark energy strengthens, the drumhead of space pulls tight until seams pop. If it fades, the map folds back on itself. Keep these maybes in a separate pocket. The main coat still fits. Expansion, cooling, evening out. Turn for home. The film runs backward in spirit, not in fact. From the hush, we return to the mid-song, where contrast thrives. Forests trade light for sugar. People trade sugar for thought. Thought turns back into light and crosses oceans at the speed limit set by nature. We remember that heat wants to spread, and meaning is the art of catching it on the way and shaping it into bread, music, shelter, and care. Give the arc a single sentence. From a warm beginning, the universe builds differences. Differences do work. Work makes pattern. Pattern enjoys a long afternoon. Then the differences fade. The work slows, and the page grows quiet. Our address is in the middle of the sentence, where pattern is plentiful and the afternoon light is kind. A bedtime inventory, simple and true. You can feel gravity by the weight of your blanket. You can measure light by the color of your lamp. You can hear expansion in the Doppler shift of a passing train, a small echo of galaxies streaming apart. You can watch entropy in a cooling cup, then reverse it locally by heating soup and warming someone's hands. The grand rules are at arm's length. Take 3 breaths with the river. Inhale for the first light that learned to travel. Hold for the stars that forged your bones. Exhale for the dark that will keep the record. Again, again. The room is the same room, now folded into a larger map. Leave a short guide for your sleeping mind. If it wanders to the start, let it see a soft fog learning transparency. If it slips to the middle, offer a blue world with weather and music. If it drifts to the end, give it a level field with a single, patient star on the horizon. No alarms, no cliffs, just the long, even breath of a universe that keeps good time. When morning comes, the rules will still be kind. The sun will rise because fusion keeps its promise. Shadows will move because Earth spins in curved space. Bread will rise because warm molecules hurry. A friend's message will arrive because electromagnetism carries it. Every small task is a handshake with a cosmic habit. Set the last frame. Night outside, a kettle beginning to sing. Somewhere far away, a galaxy lengthens to red. Somewhere nearer, a comet turns the corner of its long ellipse. Somewhere closest, you close your eyes. The river continues to the ocean, but your boat is moored for the night. That is enough. This was the pass from sunrise to starlight, to silence a gentle gradient, not a jump. Keep the picture. When you lie down tomorrow or a year from now, you can press play again and watch the arc glide by without hurry. The universe will not mind being replayed. It has patience to spare. Let the river bring us home. We have watched dawn break over the newborn cosmos, followed the gardens of stars, felt the hush of the late night, and returned to the porch light of now. The film is still running, but the frame has slowed to a human pace. You can hear your breath again. The universe has not changed. You have simply tuned to the channel where meaning is closest. Picture your room as part of the map. Walls keep weather kindly outside. A blanket is a small atmosphere, warm and held. Your body is a machine built from ancient starlight and earth. Bones remember oceans. Blood remembers iron from a star that died before the sun was born. The more you notice, the more the ordinary brightens. Attention is a lamp, and the lamp belongs to you. If your mind wanders to scale, let it wander softly. Far does not mean better. Large does not mean important. The sun is large. The strawberry is important. Galaxies are wide. The hand you hold is deep. Our long tour taught this repeatedly. Patterns matter where energy flows, and energy flows generously here through kitchens and forests and conversations that last past midnight. If fears visit, give them seats, but choose the view. Set each worry on the great timeline like a pin. Step back until the pin shrinks to a dot. Then step forward just enough to do one kind thing, answer one message, fill one glass of water. The universe is comfortable with both immensity and smallness. You may be too. When you think of the future now, let it be a horizon rather than a trap. The far endings are truthful, but they do not cancel tender work. Bread still rises. Children still learn the names of clouds. Telescopes still add faint smudges to the maps. Rockets still lift, steady and bright, into morning air. The river moves. We build bridges. We wave to boats. We nap under trees that do not know our names. You carry tools older than words. Breath is one. Take 3 slow ones with the sky. In for the first light. Hold for the stars that made your bones. Out for the dark that keeps the record. Curiosity is another. Put a question by your bed, like a book, and let sleep answer the first half. Kindness is a third. It cuts entropy locally. A room with a blanket straightened and a glass refilled is a place where energy learned a shape. Think of the people who framed this view for you, teachers who traced constellations on chalkboards, scientists who waited with cold hands for a telescope to settle, artists who painted nebulae, mission teams who threaded robots into orbit. They are part of you now. Their patience keeps your window wide. If you like rituals, make a small one from this journey. When you switch off the light, say the 3-part blessing the universe has earned. Thank you for rules that hold, for surprises that teach, for time enough to try again. Let your room darken by degrees. Let sound settle into layers. Near, near, far. The hum of the world is the same hum that filled the first fog. It is gentler now, tuned for sleep. Place the last images in order, like books on a shelf. First, the warm beginning where light learns to travel. Next, the bright middle, with gardens of suns, blue planets, and minds that send their thoughts back into light. Last, the quiet field where differences thin and the page rests. Between the first and the last sits home with a kettle singing. That is the picture to carry. If you wake in the night, do not fight the river. Count not sheep, but eras. Fog to first light to stars, stars to worlds, worlds to stories, stories to now. Somewhere, a satellite blinks across a rural sky. Somewhere, a ship's crew checks the horizon. Somewhere, a nurse adjusts a blanket and a patient breathes easier. Your breath joins theirs. The scale changes, the kindness is the same. You may be tempted to ask what it all means. Meaning is not outside the map. It is inside attention. It is a letter you write to the day with your choices. It is also allowed to be quiet, to be the way light falls on a doorframe while you pour tea. Think of meaning as gravity for the heart, a gentle curve that guides where care flows. Follow it. That is enough for tonight. Before we close, fold the timeline into a small, pocketable sentence. From a warm beginning, differences rose, did work, and made pattern. Pattern loved, asked, built, and sang. Then differences thin, and the page grows calm. Our line is in the middle clause, where loving, asking, building, and singing live. If you remember nothing else, remember that. Now let the camera stop. The kettle is off. The glass is set down. The house breathes. Clouds slide across a quiet moon. Streetlights blink in slow conversation. Somewhere, oceans lift and set their shoulders under a pull that began when the moon was born. Somewhere, under ice, water keeps a promise to stay liquid. Somewhere, a rover sleeps under dust, waiting for a sunrise thin as a thought. The universe remains vast. Your room remains kind. Close your eyes. The long river will keep to its course. You may rest on the bank. When morning comes, you can stand, fill the kettle, and step again into a day made from starlight and good rules. The lantern on the porch is yours to light. The map is large enough for wonder and small enough for care. You do not need the whole story to live a good paragraph. Good night, traveler. The timeline will be here when you wake, and so will the small, bright chores of love. Sleep until the next chapter begins, and then write it slowly, with attention, under a friendly Sunday.